All right. Good morning, everyone. Today is Monday, November the 15th. We are starting 4.08, day number 1 of 2. All right. All of you should have plenty of time to do these 3 problems. They should take you maybe 30 seconds each. What did everyone get for the first one? 2. 2 is correct. And the second one? 3.585. That sounds correct. And the last one on this page? 0.869. That is correct. All right, this was from Friday. This is Friday's lesson, doing like a change of base. So very good. All right, so solving exponential equations. The goal is, well, that. I don't know why I didn't type it. All right, make sure you got your paper, pencil, and a calculator. This is a must. This is a must. If you don't have a calculator, please do me and the rest of the class a favor. Don't hold us up when you're tabbing out, trying to type something on your other window that you may have open. Guys, for this class, you need to have a calculator, not your phone, not on your computer. I know I've said this many times. If you don't have one for next semester, it's going to be very painful. It's going to be a very painful second semester. And if you do have a new calculator and you are just curious on how to do something, like you feel like maybe you're not doing it right and there might be an easier way, just ask me. I'm kind of familiar with a lot of models, not every model. Or you can just always also Google it, type in your model number and say, how do I do this? How do I do that? Or whatever. And YouTube is a great resource for doing that. Well, yeah, Brady, we do need paper and pencil. But if you don't have a calculator today, you can't do today's lesson. You can like set everything up, you just won't be able to actually finish the problem. And typing it in is the hardest part of today, in my opinion. At least it should be. Okay, just like last week, we have these problems where you have the exponent in, or sorry, the variable in the exponent, and we have to, well, do some stuff to solve. All right, so like from last week, everyone go ahead and quickly solve this using any way that you'd like. And then give me a green check when you have finished this problem. Enzo, you still working? Done? Okay. What did everyone get for their answer? What did everyone get? So I circled it. It says round your answer to nearest thousandth place. Uh, so I do want a decimal in this case. See how I said I even circled it for you. So negative 1.5 is correct. Yeah. So like on a test, like a TGA, don't put negative 3/2 or negative 1.5. There's only one right answer, and it's the answer that is rounded to the nearest thousandth. Negative 3/2 would be your work, and then negative 1.5 would be the final answer. You forget what? Oh, oh, okay. So how did everyone do this problem? What did you do? So log base 3 both sides? Yeah, we do it that way. So I'm gonna so we log, oops. So we log base 3 the left side, and then we log base 3 the right side. And by the way, did you convert 27 to like, I don't know, something else? Like, did you write 27 as 3 cubed? No, nobody. You don't have to. Like, guys, there's more than one way to do these problems. So I'll just do it the way that all of you did it. All right, and then what happened? Divide by negative 2. Okay, so well, before that, I'm gonna guess that you meant to say do this, and then log base 3 of 3 that goes away, right? Is that what you're? And then did some of you type in log base 3 of 27 to get a number? And what is log base 3 of 27? Yeah, it's 3. It is a nice integer. Um, so when I said, so we could have actually made this into log base 3 of 3 cubed, right? Because 3 cubed is 27, and then this 3 would have moved in front, and then, that cancels out. And that's how we get 3 if we did it by hand. All right, and then from here, it's pretty easy. We just divide both sides by negative 2, and you have your answer, right? Yeah, not too bad. We also could have made the bases the same. So there's a few ways to do this problem. So I could have just rewrote it like that and said, hey, I can make both bases 3 and then set the exponents equal to each other. And we could have done it that way. Not every problem you'll be able to do that. Sometimes you can't make bases the same. In this case, we could have. So we could have done it this way and not even use log or natural log. Um, we also could have been a log or natural log both sides, or a log base 3. We move the exponent in front. And remember, we're trying to solve for n, right? We're trying to solve for n. So this is negative 2 times n times natural log 3 equals natural log 27. So what could I do? So I need to actually retype this work for this problem because I did it kind of a long, ridiculous way. So I have negative 2n natural log 3 equals natural log 27. Okay, we're solving for n. So what can we do? In one step, what can we do? And this is really important. So doing it this way is really important. It's pretty much how we're going to do the rest of the problems. No, we don't have to do that. We can just leave it as 27. That's not really going to help us. Remember, we're solving for n. So how do I get n by itself? Divide. All right. So Enzo and Brady, put your ideas together. Divide by what? There you go. Divide by -2 ln 3. Yeah, we're going to divide this side by -2 ln 3, and then divide this side by -2 ln 3. So on the left, remember, factors and factors cancel out. So these factors cancel out, and these factors cancel out. You're left with n by itself on the left. And then we want to type in, so on your calculator, type in natural log 27 divided by -2 natural log 3. And then what do you get? We obviously know the answer is going to be -1.5, but all of you that are in class or watching the recording, you need to type it in to make sure you know how to type it in. Typing it in is the hardest part of today. All right. Give me a green check when you have typed it in and you have got -1.5 after typing all that stuff in. It is very important all of you type it in and can get -1.5. If you cannot get -1.5, please speak up and let me know which model you are using, which model calculator, so I can try to help you figure out what you're not entering correctly. Okay, everyone's good. Everyone got -1.5. So this is pretty much how we're going to do today's problems. Unless, like, if you recognize a problem, you can do it like this way. This would obviously be much easier, and we can avoid doing logs and natural logs. So if you can do it this way, please do. But a lot of the problems that we're going to, like most, if not all the rest of the problems today, we won't be able to do this. We won't be able to make the bases the same, but we can try. We'll have to do this. My next, oh my gosh, the little arrow to go to the next slide wouldn't pop up. There it goes. Okay, everyone try this one and give me a green check when you have an answer. Oh, by the way, there's a slide missing about the rules of solving these equations. All right, so maybe on your notes you might want to write this down. Rules of solving an equation. Ready? Rule number 1: never round your work. So what I mean by that, if you're typing stuff in like the natural log, so let me go back to this previous page here. So for example, we don't want to type in the natural log of 3, for example, because it's going to give us like this, this decimal, or natural log 27. We get a decimal. We get a decimal that it goes on forever and doesn't repeat. You never want to round your work. Never. The only time you ever round is your final answer. So rule number 1, never round your work. Rule number 2, write this down. Rule number 2, never round your work. And then rule number 3, never round your work. Only 3 rules. Never round your work. Very, very important. You're going to have a TGA. If you round your work, I'm marking the entire thing wrong. You never, ever, 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 in any situation, want to round your work. Like in real life situations, when you're working out problems, you never want to round your work. When you round work, you create a percent error, basically what it's called, and your final answer will be off by maybe a little bit, maybe a lot. You only want to round your final answer. Do not forget that. Are these going to get much harder? Enzo, of course. Of course. I usually try to start off really easy, and then we progress to stuff that is much harder. So don't worry, this does get harder. You shouldn't have asked. All right. All right. Yeah, when you're done with this problem, give me a green check. By the way, when I solve these problems, I usually use natural log. If you want to use log instead of natural log, go for it. I usually just use ln. It's less writing. What did everyone get? 1 point, so about 1.135. Is that what everyone has? Or okay, so one point. So we got 1.153. We got a 1.154. Make sure you round properly. So either Isaiah, either you're right or everyone else is wrong, or vice versa. So the answer is 1.154. Yeah, so your final answer, let me go ahead and write this down. I see a lot of you are trying to help each other out. Give me 5 places of what you see on your screen. You got like 1.15. What? Give me like a few more places. 364. Okay. 364. So when I taught this way back in the day, we want 3 places. So I would do a line right there. And I asked myself, if this is a 5 or higher, it makes the one to the left one more. So 3 plus 1 is 4. And then we got 5, 1, 1. That's why it's 1.154. So let me just quickly show this work. So we natural log or log both sides. The v moved in front, and then we divide both sides by natural log 14. And then all of you should type that in to get that answer. Who got this one correct? Isaiah, you would have if you did make that itty bitty mistake that cost you everything. All right, not bad, not bad. Almost everyone. Looks like one of you, two of you, one of you just did a rounding mistake, one of you just did a typing mistake. So we don't round our work, we round the final answer. That's the only time we round. Once you have a final answer, then you round. All right, everyone try these two. When you have these both finished, give me a green check. All right, what did everyone get for the first one? $1.54. Very good. Yeah, 1.54. Yeah, and if you put 1.540, it's not wrong. But remember, whenever you have a decimal and the last digit is a zero, you don't have to put it. Even though it does say round to nearest thousandth, um, this is round to nearest thousandths. 1.540 that we don't have to put it regardless of this because it is rounded correctly. So either way, I wouldn't mark it wrong if you put the zero or not put the zero. Yeah. Preferably you don't put the zero. And what's the second on this page? 1.124. Yeah, very good. And I'm just quickly just show this work. All right, who got these two correct? All right, everybody, we're off to a great start. Nice job. I'm gonna the next two I'm gonna skip. It's just more of the same type. I am gonna just show the answer and the work real fast. Feel free to work on these on your own time just to see if you get the same answer. But yeah, they're just like the previous problems we just did. Nothing different about it, just more. All right, let's go into harder problems because Enzo wants harder problems. Okay, so everyone try this one. Let's do this. So when you finish this problem, give me a green check. When you get stuck or you run into a problem that you can't figure out, give me an X. And yes, I am anticipating most people will give me an X. Some of you gave me an X too soon. I don't think you even tried it. Come on, don't just give up. You need to try it. So I'm going to pick on the person who gave me an X too early. Brady, what did you run into a problem other than you just looked at it? You, well, did you try? Oh, okay, you tried. All right, okay. Shh, shh. All right, Brady, you're just too fast. Because you downloaded the guided notes and you looked ahead and tried to be one step ahead of me. Is that what's going on, Brady? Oh no, you're just that fast. Okay. So far, we got 4 people that got stuck. Nobody has finished this problem yet. Got another one that ran into a problem. We got one more. We got one more. By the way, at the 8:30 class, one person was able to finish this problem. One person out of the 7 that were there. Congrats to the person. I agree. Ken, we still working on this one? Make sure you're still chugging away. Maybe he's gone. I don't know. All right. Well, waiting for a ghost. Yep. Looks like Ken's not here. Well, this is why, guys, you come to live sessions, make sure you're actually here and you're not holding anybody else up. Yeah, not here. Okay. So, what was the problem with this? Yeah, we can't do a natural log or a log of a negative. So, I'm going to write some stuff down on the screen here. So, we know that we are not allowed to take a number and divide by zero, right? That is not allowed. That gives us a math error. So that we know dividing by zero is bad. We didn't know, but I'm going to tell you now. Whenever you do a natural log of a negative number, or you do like the log of a negative number, we also can't do that. That is also invalid. It is not possible to do that. So we never want to do that. So whenever you get a situation like this and you're like, man, I really want a natural log or log both sides, but there's a negative in front, you have to deal with it. We have to make those bases, the 18 and the 86, both positive. So Enzo said, can we just divide everything by -1? And yeah, we absolutely can. So we want to divide both sides by -1, or just divide by negative, same thing basically. And look, now they're both positive. Now everyone quickly do that and tell me what you get. You did, Brady. I ignored you. But not to be mean. Negative 0.385. You think you're the youngest, huh, Brady? Oh, are you the youngest, like in your family or in this class? In my family. Okay. Oh, you're the baby. Are you the favorite or the spoiled one? Are you the golden child because you're the last? All right. Yeah, so I think that is correct. Negative 0.385. Um, and we divided both sides by -4 natural log 18. So we all should have typed that in to get that answer. By the way, if you've forgotten, this little wavy equal sign just means about or approximately equal to. Um, so whenever I have a rounded solution, I put this about equal symbol. You don't have to. I just do. All right. Everyone try this one. I'm going to give you a little hint. If you're looking at this problem and you really want to just go ahead and either log or natural log both sides, remember, you can only do that when you have a single term on both sides. Not always, but usually. So right now we have two terms. And remember, terms are separated by plus and minus signs. So we have this term plus this term equals this term. So before you log or natural log both sides, or however you do it, make sure you try to combine like terms. So that way we only have a single term on the left and a single term on the right. You especially want to make sure that the term that has the variable you're solving for, you definitely want to have that term by itself. Definitely want to have this term by itself. So there's your big hints. Ready to go. What did everyone get for their answer? 6.6. Yeah, that sounds correct. So I'm gonna guess everyone subtracted 2 from both sides, and we get 10 raised to the v minus 4.6 equals 100. All right. Then what did everyone do? Natural log both sides. Enzo did log base 10 both sides. Or he at least typed it in, right? Log base 10 of 100 or log 100 plus 4.6 in the end, right? Yeah. Okay. So let me show you something here. Did anybody rewrite this as 10v minus 4.6 equals? Anybody do that? Now, if we happen to see it this way, and I made 100 10 squared, what can I do? Yeah, we bases are the same, so we set the exponents equal to each other to be v minus 4.6 equals 2, and then we just add 4.6. And now we avoided using logs and natural logs altogether. Ah, so this problem, we could have done it this way. But again, if you're just totally just stuck on using logs and natural logs, and it's fine. We get the same exact answer, right? We still got 6.6. Yeah. All right. Everyone try this one and give me a green check when you do this. All right, what did everyone get for this one? Negative 2.521. Nice job, everyone. Everyone else get that too? Not just 4 of you. The fifth person that's here. Yeah, Brady, Enzo, Isaiah, Isabella, Lizeth. How did you do? Close. I messed up somewhere. All right, let's figure out where. All right, Lizeth, take me through your steps. Let's figure this out together. What did you do? All right, so we log both sides. That's fine. We can do log or natural log. It doesn't matter. So just keep log on your paper. All right, and then what? Oh, did you do log base 20 of both sides? Ooh, that's actually kind of interesting. Hang on, I'm actually going to go. That is actually creative, and that's going to work. So let me. I'm so happy I asked you this because we get to see this problem done a different way. Which you might people watching this may actually like this. I did not think of doing it this way. All right, so we did because of that 20 there. This is a really good idea. You know, if I was a teacher that gave extra credit, I would give extra credit right now. But I don't believe in extra credit. All right, and then Lizeth, did you pull down the b plus 4 by itself? Because log base 20 of 20 this basically cancels out and the b plus 4 carries down, right? Okay, and then what'd you do? Well, Brady, you should have spoken up. This is kind of a good idea. And so you guys got the decimal. So you subtract 4. Okay. So you don't want to type that in yet. Remember, you'd never want to round your work. We only want to round the answer. So you subtract 4 both sides. We have log base 20 of 84 minus 4. So if you have or Elizabeth, which model calculator are you using? Oh, sweet. Good. All right. Okay. Clear your screen. I'm going to tell you how to enter this really, really easy. The rest of you, you're going to wish you had a Casio model if you don't already have one. All right. So once your screen is clear, you have the blinking cursor. The very top right button below the on button, you have a log base something or other. It's the button right below on. Hit that one time. And look, now you have boxes to enter the base and also what you're logging. So in that first little box, obviously put a 20 and then scroll to the right and enter, was it 80, 84? 84. And then scroll to the right and then type in -4. So I show my screen. Let me see if I can actually show this. Uh, let's see. It's too dark. It's too dark. It's not working. It's not working. And yeah, I tried. It doesn't work. I don't have enough lighting. Uh, but Lizette, you should have gotten that and then hit enter. Can't hear me? Hello? All right, Lizette, can you hear me now? Can you hear me now? Okay. So you want me to start over what I just told everyone about entering it? Yeah, no problem, no problem. All right, so on your Casio model, clear your screen, and the top right button, right below the on button, it's like log base something of log. Hit that button. So it's the button right below the on button. You hit that one time, and it gives you the log, and it gives you 2 blank boxes. So the first blank box is where the cursor's at. Type in 20. Scroll to the right 1, and then type in 84, and then scroll to the right again to get outside the log, and then type in -4, and then hit enter. -252. Is that what we said it was? Is that right, everyone? I don't know. I think so. Yeah, -2521. Let me just, where'd my pen go? How cool is that, Lizeth? Is that cool or what? Oh, okay. So you forgot to scroll outside of the box to put -4. Yeah, that would definitely change your answer. All right, all right. See, this is the beauty of coming to class. We get to figure out what you might be doing wrong. Um, as simple as it seems. All right. So yeah, this is actually a really cool way. I'm really happy that we brought this up because it kind of in a way simplifies the work. And again, if you have a calculator that you can actually enter this in, like the Casio 115 and 300 will do this. If you have a model that does this, you don't have to do a change of base. We don't have to do log or natural log of 84 divided by natural log or log of 20. We can just enter it like this. So that's nice to have that. Um, Another way to do this problem is if you did that and then we brought the exponent in front and then we divide both sides. So we don't want to distribute that natural log 20. We could. We're just going to make the problem look kind of crazy and then it creates a lot more steps, but it's not the end of the world. We can actually still finish the problem if you did do it that way. You just really don't want to. But we want to divide both sides by natural log 20. And then from here, we subtract 4. So in a way, this kind of looks like what we just did. It's just this was our change of base, right? Natural log 84 divided by natural log 20. If we go back to the previous page, natural log of 84 divided by natural log of 20, it's just change of base. Basically the same thing, though. Yeah, this is cool. I agree. This is such a great model, and it's a lot cheaper than the TI. The TIs well, overpriced, in my opinion, but it's worth the money for a graphing calculator if you need one. I feel like you're just no, Enzo. Get me wrong. I have where is it? I have a I have a TI. What is this thing? I got a TI 89 titanium, and then I haven't even taken out the wrapper off this other one. I got a TI 84 silver edition that I also haven't. I turned it on. I just haven't actually used it. It was still on the floor right next to me. Whoops. Anyway, because guys, we don't need graphing calculators in this class. Like they're really helpful if you know how to use it. Um, but yeah, this $10 one or 15, you got the 115 is more than adequate. The TI was $20. Yeah. I'd rather spend 10 for the FX 300, in my opinion. But anyway, let me show you a different way to do this problem. So this way that Lizeth did it is, I would say, probably the easiest way. And then followed by maybe doing this way if you just didn't do it the way that Lizeth did, or Brady or Enzo. Let's rewrite this as 2 factors. So think back last week. How can I rewrite this as 2 factors? It was the same base property of separating them or combining them. How do we do that? So Yes, that wouldn't be wrong. However, I I wanted you to separate this so that way we don't have two terms in the exponent. So Enzo, you're not wrong, but it also doesn't help us either. So rephrasing what I asked, I want you to rewrite the left side with two factors with a single term in the exponent. Sorry, my fault for not being specific. Nope, nope. Don't jump right to logs yet. We want to just rewrite that 20 raised to that power as something else. Think back to last week. So remember last week I had a slide and I had a box up here and it was like it was filled in with blue and it was the same base property and we had to use it to go backwards. That ring a bell? Yeah, some just not ring some bells is not enough. All right, let me just show you. It's like you forgot. You forgotten. That's all right. Does that look familiar? We can separate it to be 20 to the b power times 20 to the 4. Remember, same bases, you add exponents. So going reverse, you can separate them. Oh, yeah, that looks familiar. Yeah, and again, this is probably, I wouldn't say it's the worst way to approach this problem. I'm just showing you a different way to approach this problem. And again, this is probably the last way that I would do this, but still wanted to show you. All right, so we separated this to become a single term exponent, same basis, of course, because it's the property. And then from here, we can divide both sides by 20 raised to the fourth power. And from here, we could type this in. We would have a really big number and we could simplify this fraction, but there's really no reason to. We can just leave it like this. And in my work, I just leave it like this just because we're going to have to still do more steps. So from here, we could do log or natural log both sides to get this. Then the b moves in front. And then I can divide both sides by natural log of 20. Oh, by the way, this natural log of this fraction here, um, if you want to put parentheses around it, like it does on your calculator, it forces you to have parentheses. We can. And I just wrote that to the right just to show it. But you don't have to have parentheses when you actually show your work. But it might help just keep things organized. So everyone, go ahead and type this in. Let's make sure you actually can type this in and still get the same answer. So natural log of this fraction divided by natural log of that number. Then hit enter. All right, just give me a green check after you type it in and you got the same answer. Okay, good. Good. All right. Again, this is probably I would probably not recommend doing it this way. This way on the left, or how Lizeth and a few others did it, is definitely probably the way to go. All right, so we got this one, and we got two more problems, and then we'll stop. All right, everyone, work on this problem and give me a green check when you finish it. All right, what do we get for the answer? Anybody else? Negative 8.523 is correct. Yep. Okay. Did everyone divide by -8 to start this problem? Okay, that would be correct. We divide by -8. And again, don't round your work. We have to keep it as a fraction. If you want to leave it as 62 over 8, that's fine. Or if you want to reduce it like I did, you can. You just don't want to round your work. Simplifying it, like reducing the fraction, that's okay. All right, and then did we log or natural log both sides? So, and we could have log base for both sides. That might save a step. But yeah, you could have log base for both sides. That's fine. I went ahead and I natural logged. I kind of like the idea of log base for both sides. It kind of makes the work look a little neater and less complicated to enter. We're going to move the n plus 10 in front. And then we are going to divide both sides by natural log 4. And then we subtract 10. Now, if you log base 4 both sides, you would have had, in that last step before actually typing it in, you would have had log base 4 of the fraction 31 over 4. And then minus 10. So that's the only difference if you just log base 4 instead of doing what I did. But typing that in, you should get that same answer. And again, make sure when you type it in, log base 4, you scroll over, you type in 31 over 4. The Casios have a dedicated fraction button. So you hit that button and it puts a box top and bottom that you can enter 31 on top, 4 on the bottom, and then scroll to the right and put minus 10. All right, everyone's good. They found their mistake, small or big, typing mistake. Okay. Good. All right, last problem of the day. I know I'm going over time. It doesn't sound like me at all. All right, applications. Word problems, my favorite, and your favorites too. You deposit $1,000 into an account with an interest rate of 2% that compounds daily. How long, that's a typo, how long will it take to have $2,000 in the account if no money is withdrawn or deposited? Round the answer to the nearest thousandth. Right. So we probably need to use a formula, right? Which formula do we need to use? Yeah, that compound interest formula. Now, if you downloaded my guided notes, I'm pretty sure it's on there. But there it is. If you have forgotten and you don't have it in front of you. So we got all this information. We need to basically plug it in. So when we start these problems, we really want to write down everything we know. So maybe we know what A is. Maybe we know what P is. Maybe the R value, the N value, and then our T. All right, let's write this stuff down. Do we know what A is? A is, yep, $2K, $2,000. Remember, A is the amount in the end, and we want to know how long it takes to get to $2,000. So yeah, it tells us the ending amount is $2,000. What is our P value, our starting amount? Starting amount is $1,000. Yeah. What's our rate? Yeah, 0.02. Yeah, don't forget, everyone, we must convert into a decimal, and 2% becomes 0.02. What does n equal? 365. Yeah, because n is the number of compounds in a given year, and it's compounded daily, so that would be 365. And what does t equal? Yeah, we don't know. That's what we're trying to solve for is the times. Yeah, so I'm just gonna put a question mark. Yeah, I don't know. What is t? So let's go ahead and take everything that we wrote down and let's plug it into the formula to set it up. And then confirm that what you have and what I have are the same. Let's do this. Let's see who can actually solve this. I know we're over time. If you have to go to another class, that's fine. Just bounce out of here and just watch the recording later and watch the end of it. I'm sorry. Other teachers' time, I consider it's their time, and I shouldn't go over. That's why you guys need to leave if you need to go to the next class. So math is the most important class. It's also the hardest class. All right. So yeah, just give me a green check when you finish this problem. Yeah. Maybe I'm naive to saying this, but in my opinion, um, math and maybe physics are probably two of the classes you can take in high school that if you miss one day, the following day you're going to be so lost. But in other classes, you could miss maybe one or more days of a different class and probably will be able to catch up relatively easy compared to math. Um, and that's just my opinion, of course. But what do I know? Oh, geez, everyone's leaving my class. Well, three of us left. Well, four if you include me. Right, Lizette, how we doing? Oh, that's all right. Let's go through it together. Enzo, were you able to get an answer? 34.658. Let's see if that's right. 34 point. Yeah, that is correct. Yep, you did get it right. Let's take a look. So we divide both sides by 1,000, and we get this. Um, and then what can we do to both sides? Yeah, convert it into log. So we can either log both sides or natural log. Again, I like using natural log. That's just me. Natural log both sides, and then what can we do? What is our next step? Enzo, what do you mean you use the formula? Did you just guess and check? So what do you mean you use the formula? Oh, you okay? So you actually use the conversion formula versus what I'm doing. Okay, yeah, that is one way to do it. I don't like using that change formula just because it's well, I'd rather just do the math. So from here, we can move the exponent in front of the natural log. So we get natural log of 2 equals 365 times t times natural log of all that stuff. And then remember, we are solving for t. So we want to divide both sides by 365 natural log of all that stuff to get t by itself. And then we want to type all of that stuff in. So everyone do that and let me know when you got that. All right. So in this situation, doing it how Lizeth, how you been doing it and doing like log base of whatever this is, it doesn't really work. Not really. It can. It's because the base is no longer just a single number. It's this quantity. So it's not as straightforward as the previous problems, and that's why doing it this way um, allows us to well finish the problem without hopefully much issue. Because we really don't want to have like a log with a log of a base with like all of this stuff. It looks really weird. All right, everyone able to get that answer? Everyone good? Any questions before we stop? Any questions? No questions? All right, well, good. All right, guys. Well, as always, thanks for coming and sticking around. And I hope you learned something. I will see all of you tomorrow for our very last lesson of the semester. Well, it's not. It's our last new material lesson. So we have tomorrow's our last lesson, new material, and then we of course we have the reviews and the exam, and then the final exam review and the test. But tomorrow's going to be the last day of new material that we're going to learn. How exciting is that? All right, everyone. Take care.